We've been talking over the last few chapters about electricity. We are now ready to start talking about direct currents, which is the topic of Chapter 19. In Chapter 19, we'll be talking about electromotive force, or EMF. We'll be talking about connecting resistors, either in series or parallel circuits. We'll talk about how to calculate the current through resistors. A few simple rules to help with those calculations. And then we'll also talk about capacitors in series and in parallel. Let's start off in this video talking about electromotive force, or EMF, and terminal voltage. All right. So every electric circuit needs some voltage or some electric potential that can drive the current. So we usually use a battery or a generator to produce that current. These sources are what we call electromotive forces, or EMF. Now, it's an electromotive force is not necessarily an actual force, but it does provide the potential energy needed for charges to move within a circuit. And so we kind of casually refer to it as an electromotive force. Now, batteries provide a particular voltage. For example, if you grab a AA battery, it's labeled having a voltage of 1.5 volts. A car battery would be 12 volts. However, within the battery, there is a little bit of internal resistance. There are charges moving around inside the battery, and so as a result, you do have a little bit of resistance, and so you lose a little bit of voltage that way. So when you calculate the voltage from terminal A to terminal B, then that terminal voltage would be equal to whatever EMF your battery supplies minus the voltage lost due to internal resistance. And we know from Ohm's law that any voltage can be calculated as the current times resistance. So terminal voltage is equal to EMF minus IR, where R is the internal resistance of your battery. Now, the resistance within a battery behaves as if it were in series with the EMF. Now, we'll talk more in the next video about what it means to be in series, but in short, that just means that it is in a straight line. So in a circuit, you might see some voltage source here, and then we can often indicate your internal resistance like so. So it's as if they are just in a straight line within a circuit with each other.